Starship HLS, the human landing system, is SpaceX's lunar variant of Starship, selected by NASA to return astronauts to the Moon for the first time since Apollo. Artemis III, the mission planned for mid-2027, will rely heavily on it. To support this, SpaceX will build 3 different Starship versions: the Starship HLS, a tanker variant, and a dedicated depot version. The tankers will launch repeatedly from Earth to refuel the depot in low Earth orbit. Once Starship HLS reaches orbit, it will rendezvous with the depot, dock, and fully refuel before beginning a journey to the lunar surface. For SpaceX, Starship HLS is more than a moonlander. It's a full-scale test of their Mars architecture. It can deliver over 100 metric tons of cargo and offers a massive pressurized volume. There's simply no comparison to the tiny Apollo moonlander. But for NASA and the US government, Starship HLS is both ambitious and oversized. Meanwhile, China is making rapid progress in its own lunar program, and Washington is increasingly concerned that the US may fall behind. This is why NASA recently reopened the HLS contract for competitors such as Blue Origin. A decision Elon Musk was not happy about, and he made that clear in several posts on X. One of the most critical and least tested elements of the entire mission is orbital refueling. No one has ever transferred cryogenic propellants on this scale in space. There were indeed experiments in the past, and as early as 1984, the Space Shuttle Challenger demonstrated the orbital refueling system, proving that refueling satellites in orbit was feasible. But none of those tests involved cryogenic propellants, thousands of tons of propellant, a complete tank-to-tank transfer, orbit-to-depot missions. It's not even known how many tanker flights will be required. Current estimates range from 8 to 16 launches, and orbital refueling comes with serious technical challenges. The boil-off problem. Boil-off happens because sunlight and thermal radiation slowly heats the propellant tanks in orbit. Even small temperature increases cause liquid oxygen and liquid methane to warm up and evaporate. SpaceX plans to counter this with a combination of active cooling, multi-layer insulation, and rapid propellant transfer to minimize the time the fuel is exposed to heat. These methods are essential because Starship will store cryogenic propellants in orbit far longer than any spacecraft before. Transfer losses. No system is 100% efficient. Fuel trapped in lines or lost during venting can't be recovered. For rendezvous operations, Starship will use Dragon Eyes navigation sensors, a system with extensive flight heritage from the Dragon spacecraft during dozens of dockings with the International Space Station. This gives SpaceX a major advantage. The core technology is already proven. The elevator problem. Unlike Apollo, which had only a small ladder leading down to the lunar surface, Starship is massive, as tall as a multi-story building. That means astronauts must rely entirely on a long mechanical elevator system to get to and from the Moon's surface. This creates a serious single point of failure. If the elevator malfunctions, astronauts on the surface could be stranded. And while SpaceX will likely add manual backups, such as a hand crank mechanism, operating such a system in a bulky lunar spacesuit would be extremely difficult. The stakes are far higher than in Apollo. A fall from Starship's height would be fatal. Recent moon missions from several countries have shown just how difficult lunar landings truly are. We've made an entire video about this topic. For Starship HLS, the challenge is even greater. The vehicle is enormous, heavy, and has a high center of gravity, nothing like the Apollo lander. But if any company has demonstrated an ability to solve impossible engineering problems, it's SpaceX. Inside, the living volume of Starship HLS is 613 cubic meters. For comparison, The entire International Space Station, a structure assembled over 25 years, offers only 388 cubic meters of habitable space. Starship HLS is not just a moonlander. It represents a new scale of human presence beyond Earth and a major step toward making humanity multiplanetary. Do you think NASA chose Blue Origin just as a backup, or do they doubt SpaceX? Let me know in the comments.